is Raghav and the topic of the science fair is Archimedes principle. Why I chose this project is because when I was swimming in my pool and got out of the pool, I felt a lot heavier. And when I went back in, I felt a lot lighter. And I wanted to know why this was happening. And I realized that this was all explained in Archimedes principle, which states that when a body is immersed fully or partially in a fluid, it experiences an upward force which is equal to the weight of the fluid displaced by it. And now I'm going to show a real life example of Archimedes principle. So I have a spring balance and a sand weight over here. And if I weigh this, it shows 2 Newton, which is equal to 200 grams. And I will write that down. And now, if I put it in water, it decreases to 0.8 Newton. And it decreases because of the buoyancy, which is basically the upward force an object experiences when it's placed underwater. And to get the buoyancy, we need to subtract the real weight from the apparent weight. The real weight is the weight outside water and the apparent weight is the weight inside water. It is called apparent weight because it appears to be a different weight. And since the real weight is 200 grams and the apparent weight is 80 grams, the buoyancy will be 120 Newton. Now we are going to find the displaced water. And I have a 300 ml filled beaker. As I am immersing the object into the water, it raises until 420 ml. So the displaced water is actually 120 ml. Let's find out the weight of and the displaced water. So the empty cup weighs 32 grams. And let me add the water. Which is also 120 grams, 120 ml. The total, it weighs 152. And if we subtract 152 from 32, we will get 120, which is the displaced water and also the buoyancy, thus proving Archimedes' principle. But why and how did Archimedes come up with this principle? Well, there's actually a story behind it. Once upon a time, in ancient Greek, there was a fellow named Archimedes who was born on 289 BCE in Syracuse, Sicily. One day, the king of Syracuse asked his goldsmith to make a crown for him, and when it was done, he suspected that the goldsmith had used a little bit of silver, but he could not prove this. So he called in his most intelligent scientist, Archimedes, to help with this problem. But Archimedes did not know how to solve this at first. So, thinking about this, he went to go take a bath in a fully filled tub. And when he climbed into the tub, he realized that some of the water was overflowing. He also realized that the more he sunk into the water, the more it was overflowing. And after he realized this, he jumped out from his tub and ran out in the streets shouting, "Eureka, Eureka!" which in Greek means, "I have found it." And what did he find? He found the answer to the king's problem. Well, you see, all he needed to do was get a lump of pure gold and get the crown and give them a bath. So all he needed to do is, if he took the crown and a lump of pure gold and put them in 2 different jars of water, and if they displaced different amounts of water, then the goldsmith has cheated. But what if the goldsmith has used maybe 10% silver? Then it would be too hard to notice the difference between the two. And that's how Archimedes came up with the brilliant idea. 2 bags, but but I don't have a lump of pure gold and a crown. But I can prove this with two different materials. I have the sandbag. I have one sandbag. I have two objects that weigh the exact same. One is a rice bag and one is a sandbag. And as you can see, the sandbag actually had more density, just like the lump of pure gold, and the crown was actually the fake, which actually also proves that the crown was actually fake. And why do ships float? We all know it's because of buoyancy, but how is the buoyancy more? I mean, even a small penny sinks, and a ship is way heavier than that. Well, it actually has to do something with its shape. A ship is actually designed to displace as much water as possible, which increases the buoyant force. And also, the bottom part of a ship is actually mostly hollow. And the ship also is actually not just it's not a squared shape, but the bottom part is actually a little bit curved to increase stability and help it not tilt side to side, but just go in a straight formation. Thank you.